Hi there, folks. Today we're looking at solving using square roots. And this is just another method that we use to solve quadratics, but it only works for certain quadratics. It only works when we have quadratics that only have a squared piece and they don't have that individual x piece. So like when it's in that format of like x squared plus an x term plus a constant, this doesn't typically work unless we modify the equation first, all right? So when we have just something squared all by itself, or that we can get by itself, that's when we want to use the square root, okay? If we can isolate that squared term and not have a variable anywhere else, all right? So solving using the square root, to undo squaring something, we're just going to take the square root of each side, all right? And we've already solved equations that had square roots in them, and we got rid of the square root by squaring each side. So it would make sense that to get rid of squaring something, I square root each side, all right? So it's just that idea of inverse operations. For example, if I look at this first one, here I've got x squared equals 9. And so to do this, what I do is I just say, hey, to undo this x squared, I take the square root. And whatever I do to one side, I have to do to the other side. Okay? And you might be looking at this going, you know what? I know the square root of 9, that's a 3. But of course, that's not quite right. And the reason it's not quite right is because there's this little technicality, and I mentioned it, but we kind of ignored it since I mentioned it, is that actually the square root of x squared is really the absolute value of x. All right? And that just goes back to the nature of square roots and that kind of thing, but it's technically the absolute value of x equals 3. And to solve this, what you have to do is you have to split this up. Remember, absolute value equations, we see what's inside there equals this thing, and then what's inside there equals the opposite of this thing. So I actually get two answers. I get x equals a positive 3 and x equals a negative 3. So I need both of those answers. And when you go back to the original problem, that makes sense, because if you look at the original problem, something squared equals 9. Well, if I do positive 3 squared, yeah, of course it equals a 9. But if I do negative 3 squared, negative 3 times negative 3 is also a 9. And so I get these two different answers, okay? Same thing with the next one. If I take the square root of each side, well, technically, the square root of x squared is the absolute value of x, and then the square root of 49 is a 7. But now I'd have to split this up and say, oh, x equals a 7, or x equals the opposite of that, which is a negative 7. So I get two answers of negative 7 and positive 7. And if you're looking at this thinking, well, doesn't that mean that just each time I take the square root, I'm going to get a positive version and a negative version? Yes. So do you have to write the absolute value every time? No. All right. We just have to remember that, hey, when we take the square root of each side, we're going to get two versions of this thing. We're going to get the positive and the negative. So like here, I take the square root of each side. And for this one, that gives me an x. Over here, instead of doing the absolute value of x, I just said x. So that means I have to do a positive square root of 22 and a negative square root of 22. So I get two answers, okay? And as shorthand, you could write it like this. You could just say plus or minus the square root of 22, all right? Same thing with these guys. You don't have to write them separately like that. You could write this as x equals plus or minus a 3, and it means that I have a positive and negative. Same thing here, all right? You could say x equals plus or minus the 7, all right? And it's just shorthand for a positive and a negative. It's a nice way to write it, okay? And this is kind of the first time we've seen that a lot. We've seen plus or minus signs in front of square roots before, all right? But now we're kind of applying that to a situation, all right? And so again, we don't have to remember the absolute value. Yeah, it's the technicality that causes this to happen. But really the thing we need to remember, the little shortcut here is instead of doing the absolute value, whenever we take the square root of each side, we have to remember to do plus or minus that thing, okay? And as I continue this thing, really, it's just a matter of me understanding how all equations are solved from here on out. See, now that I know to undo x squared, I can do the square root. Now I just work backwards through order of operations like I've always done, remember? So I undo addition and subtraction, then I undo multiplication, division, then I undo exponents and roots, and then I undo parentheses, which are inclusion symbols, okay? So here, I would undo the addition first by subtracting the 1 from each side. And then I would undo multiplication by dividing each side. See, I'm just going backwards through of operations like I've always done. And now I would undo squaring something by taking the square root of each side. And so that would give me x equals, I just have to remember because I took the square root, that I got to do a plus and a minus. And now I have to simplify the square root of 8. Remember, we break that down into a 4 times 2. The square root of 4 is a 2, so I get x equals plus or minus 2 root 2. And yes, we are going to be simplifying radicals. If I ask for an exact answer, I'm asking for this. I'm asking for you to leave it in radical form. All right. If I ask you to estimate, then of course you would plug it into a calculator and get a decimal. All right. If I look at this one, again, on this one, you might want to try adding the 2 to each side. You're going to feel tempted to do that, but you can't because it's in parentheses, and I undo parentheses last, okay? So I have to start outside the parentheses. The only thing I have outside the parentheses is the squared, so I undo that by taking the square root of each side. And so what happens is the square and the square root cancel out. I get x minus 2 equals, well, that's going to be a plus or a minus 6. So I literally have two values there. I have a positive 6 and a negative 6. And now I can add the 2 to each side. And maybe you're looking at this going, well, how in the world am I supposed to do plus or minus 6 plus 2? Well, plus or minus 6 literally means two things. So you literally have to do this twice. So I do a positive 6 plus 2 and I get an 8. And then I do a negative 6 plus 2 and I get a negative 4. Okay? And that's it. The plus or minus means I have two things, so I literally have to do two things, okay? If I look at the next one, again, because that x plus 6 is in parentheses, I have to undo what's outside of the parentheses first. So I take the square root of each side. The square and the square root cancel out. Over here, that gives me a plus or minus 4. Remember to do the plus or minus whenever you take the square root of each side of an equation. And now I subtract the 6. And now, once again, I think about what this means. I have a positive 4 and a negative 4. If I did the negative 4 minus 6, I would get a negative 10. If I did the positive 4 minus 6, I would get a negative 2. So I get two answers because I had two things over there. I had a positive and a negative 4, so I have to subtract the 6 from the positive 4 and from the negative 4. Okay? This one, same kind of thing. To undo that square, I take the square root of each side. And now I'm left with the x minus 3 equals plus or minus. Don't forget that plus or minus. And then, of course, the square root of 50, I can break that down into a 25 times 2. Square root of 25 is a 5. The 2 is still trapped. And if you still need to show that step or take that thing off to the side, that's fine. Okay? But some of us are starting to be able to do that in our heads. And now I'm going to add the 3 to each side. And now here's the thing. If I look at this, these are not like radical terms. Remember, I can only add terms that have the same radical. So the 5 root 2 and the 3 can't be added. So I just leave them separated. I have the 3, and then I want to add the 5 root 2, and I want to subtract the 5 root 2. So I leave it as 3 plus or minus 5 root 2. I don't finish combining these because they're not like terms, so I can't finish combining them. And again, if I want the exact answer, that's what it looks like. But if I ask you to estimate this thing, you would plug those two things into your calculator. You would hit 3 plus 5 root 2, and then you'd hit 3 minus 5 root 2. You'd have to plug in two separate things. And I will ask you to do that when we practice some of these things, okay? If I look at this guy again, I want to undo what's outside the parentheses. So now outside the parentheses, I have a 1/2 and I have the squared. I want to get rid of that 1/2 first. Remember, to get rid of 1/2, you multiply each side by 2. So now that leaves me with an x minus 2 squared equals 8. Now I can take the square root of each side. And once again, just remember to do the plus or minus here. And now simplify that radical. That's a 2 root 2. Again, take it off to the side. Look for those perfect squares. Do your factor tree if you have to. And now I'm going to solve by adding the 2 to each side. And once again, I'm in a situation where I do not have like radical terms, so I just leave them separated. Okay? I leave them separated. And this is probably a good time for me to show you how to plug it into the calculator. Okay? So if I pull my calculator up here, I just got my my good old Casio. So if I asked you to estimate this, I don't want to do it with all of them because I don't want to waste a bunch of time. Most of us are going to be okay plugging this in. But keep in mind, it is two things. So like this one says 2 plus 2 square root of 2. And so that just gives me one of my answers, 4.83. So if I asked you to estimate this thing, you would say, oh, that's x equals 4.83. And then you have to do this again with the subtraction. So you do 2 minus 2 root 2. Don't go looking around on your calculator for a plus or minus button. It's not there, all right? You have to understand that the plus or minus means I have two things. You have to plug in the plus, and then separately you have to plug the whole thing in again with the minus, so I get a negative 0.83. Okay, so that's what you would get if you estimated this thing. Okay, so again, estimation, exact answer. Okay, so keep that in mind. I can ask you for either one of those. Make sure you read the directions. All right, so the rest of these, I'm just going to keep doing it in exact form, but please understand how to estimate this. All right, so for this one, again, working backwards sort of operations, I undo the addition and subtraction first. So here I'm going to add the 4 to each side. Again, still working outside the parentheses. Next, I'm going to undo the multiplying by 2, so I divide each side by 2. Now I have that squared isolated. It's the only thing left outside the parentheses, so I take the square root of each side. Don't forget your plus or minus here, so it's plus or minus. I just leave it as the square root of 11, and now I subtract the 1. And so once again, the exact answer here is x equals a negative 1 plus or minus the square root of 11. And that's it. I leave it in that form. Again, if I wanted to plug it into the calculator, I have to do it twice. Negative 1 plus that thing and then negative 1 minus that thing. Okay? If I leave this guy, again, working backwards through row of operations, subtract the 4. And now again, to get rid of a 1/4, I'm going to multiply each side by 4. Remember, that's how we get rid of fractions. Now I take the square root of each side. And so I get x plus 1 equals, well, the square root of negative 8. Can we take the square root of a negative? No, not yet, okay? In Algebra 2 here, you would continue this problem and get some imaginary answers. But for Algebra 1, we're going to stop right here and say, wait, this is impossible for us, and we're going to say no solution, okay? In reality, it's no real solutions here. We have imaginary solutions, but for our purposes, we don't take square roots of negative yet, so we're going to say no solution, okay? The next one, again, I don't have parentheses this time, so I just start undoing stuff. I subtract this 15 from each side. And now I can divide each side by this negative 2. And now I can take the square root of each side. We're just stepping backwards sort of operations. The only reason that I was saving some of that stuff earlier is because it was in parentheses, all right? So be aware of the different situations. And that's it. And again, don't forget the plus or minus, okay? And then we get something like these guys, all right? These guys are kind of special. If you've hung with me so far, these guys are kind of a preview of what we're going to do next with these things, all right? You might think, hey, why don't I subtract that 5 and then start trying to solve using the square roots? But the way this one is written, you can't solve using the square root because I've got an x squared and then separately I have an x, okay? And so if I isolated the x squared, you see I'd be taking the square root of something with an x and it's no good, all right? It doesn't fit the formula, all right? So for this one, I would have to rewrite it in a way that I could take the square root without getting an x trapped underneath there somewhere, okay? There are two ways to solve this particular example. You could subtract the 5, get it equal to 0, and now build a bridge and solve by factoring. But I can build the bridge the way this one is because this is a special kind of trinomial. When I build a bridge, two numbers that multiply to a 25 but add to a 10 are a positive 5 and a positive 5. And so what I get is x plus 5 times x plus 5, which is x plus 5 squared. And so now you can kind of see what this thing looks like. It looks like all the rest of the examples we've been doing today. I take the square root of each side. And so I get a plus or minus here. And you're probably thinking, well, why would I do this? Or how would I even know that I should build a bridge the way it is? Well, if you subtract that 5 and try building a bridge, guess what? It's not going to factor, okay? And so the method we had previously learned for solving something that looks like this won't work on this one. So this is one of the few ways that I can do it, all right? And what we're going to learn in the next lesson is how do I get it to this format so that I can get to this situation where I can take the square root, okay? This one's the same way. If you factor this thing, build a bridge, two numbers that multiply to a 9 but add to a -6, or a -3 and a -3. So this is x minus 3 squared equals a -1. And now I can take the square root of each side. And I get no solution here because I can't take the square root of a negative yet, okay? And so the idea here is there are certain quadratics that cannot be solved, all right, by factoring, which is the first method we learned. But there's also certain quadratics that are not set up for solving using the square root. And so what we're going to figure out is how can I write it in a way that I can use the square root, all right? And the reason I want to do that is because that will work every time, okay? So solving by factoring doesn't always work, but if we can get it to a format where I can take the square root, I can always do that method, all right? So keep that in mind. This is a preview for the next lesson, okay?